Okay. Oh. Yesterday I completely forgot to announce the stream. We are not gonna repeat the same mistake today. So we're gonna announce the stream here on my server, Discord server. You guys are more welcome to join if you want to. The Discord server is this. Let's see if the bot works. So you can join using this link here. And let's announce this also on Godot server in Discord. Okay, that's this is also on. And let's go here, copy that. So you will make our timestamps. Okay, so that one is learning voxels, followed by Zylann. So copy that. And the stream is at 13:00, and of course today is 10th of May 2022. Okay, right, so 8:30, so let's say 9 stream goals, and we'll see how we go from there. How is the bitrate? The bitrate seems to go well. I don't see any problem. There is a bit of delay. Still, there is a bit of delay on the video. Yeah, even though the bitrate is really high. Okay, anyway, so welcome everybody. Welcome to the stream. What we're going to be doing today in this stream is going to be examining voxel tools. And what is the voxel tools? Is that we saw yesterday, for those that are new to this, voxel tools is a module, a Godot module by Zylann, which basically what it does, it allows you to have voxelized environments. So voxelized is, for those that don't know, it's Minecraft stuff, like for example the Minecraft kind of look, where you have the typical look of Minecraft here, but also you can have things like a normal terrain. Why we need those things? Because it's for those of us that we do sci-fi games or games that have some kind of infinite terrain, where you're not going to sculpt the terrain, you're going to use some kind of randomizer that will allow you to make some generic stuff that will be, infinite, because what I'm creating, of course, is a sandbox, and having to model everything is going to be pretty much insane. So because I want to try to make something very similar to No Man's Sky, to Elite Dangerous, of course, it's not going to be as cool, it's not going to be as, as detailed and realistic as those games. It's going to be low poly, and it's going to be much more, single-person project than those games that are made by, in some cases, big companies. And even smaller teams. No Man's Sky started as a small team, and then they grow up as a team. But I'm not trying to make everything procedurally. I'm just trying to use procedural terrain. And the idea was to make my own procedural generator for terrain, but then I was aware always of voxel tools by Zylann. I know that this is a module that you compile with Godot edging. For those that don't know, a module basically is nothing more than a fancy word of saying that you can add some source code to the Godot engine that will extend the Godot engine, and then you're going to build a new Godot engine out of that. So it's a way to extend the Godot engine. And this is exactly what this one is. This is actually added to the Godot engine source code. It's compiled together with the Godot engine and gives you a huge library of utilities that allows you to build your own terrain. But also it's not used just for terrain, because voxelization is a complex process which allows you to take something that's mathematically defined and turn it into an actual mesh. So using triangles and all this kind of stuff. So the method I was looking at was, of course, cube marching, which is a way to take cubes inside the space, see whether the mathematical geometry intersects with those cubes, and generate faces out of those cubes. So it's what we call a mesher. A mesher is basically something that takes something that's mathematically defined using mathematics. Usually we use things that are called science distance fields. And basically they measure the distance between the surface and a sample point. And then you actually try to make triangles out of that, because the GPU, you don't have to make triangles. I have actually created what called a ray marcher, which is a rendering engine that allows you to take mathematical geometry and render it directly to pixels. Because if you think about it, even triangles in the GPU doesn't really exist. In the GPU, in the end of the day, all it understands, because when people say, oh, GPU understands triangles, no, actually it doesn't. The only thing that GPU understands is pixels. That's what it cares. It's just that it has also hardware acceleration for mathematics done on triangles. So it also represents the 3D geometry, obviously, in triangles. But in the end of the day, the final product of a GPU is always going to be pixels, which is the final process we call rasterization. So you can make your own render engine, which also can run on the GPU side. You use the traditional rasterizing method. Making an array marcher would allow you to take directly a science distance field, something that's procedural generated mathematically, and render it directly to pixels. However, we do things here differently. We bake something that's mathematically generated, we turn it into a mesh, or we turn it into triangles, and then the GPU will turn it to pixels. And and this method is better because it allows you to take advantage of the hard acceleration of the GPU, and it allows you to do things that you can do you can access, of course, the tools of the engine. So you can do texturing, you can do lighting, you can do animation very easily. Things that you will not be able to do in a render engine that does directly the rendering, because then it has to facilitate for all those things as well. So using this method allows us to have something that has an infinite amount of detail, because the detail is rendered based on the distance. So you can have this becoming more and more detailed the closer you go to get to that, because it uses some kind of level of detail voxels in essence. So that means that it's going to use bigger voxels. Voxel is a cube basically that will make a geometry that is lower poly in the distance. And the reason behind that is because everything in the distance, because of perspective, is becoming smaller and smaller. You don't really see that this one, for example, this thing here is much less detailed than this one. For you, it appears like the terrain is basically the same. It's of the same detail. But because of the perspective, of course, lowers the detail, makes things appear smaller in distance, you don't really see that. So we use lower detail in distance. This is the typical low level of detail stuff you're doing when you use models inside Godot. And that's the beauty of this tool, is that it handles all these fun things for you. It handles the voxelization, it handles the level of detail, it handles the texturing, it handles the physics, because now you can take this terrain and sculpt, because that's something important for me, because I want to do mining in the game. So yeah, you can do pretty great stuff. So the goal of this stream is to read the documentation, go through the documentation, starting testing the tool. We started testing it yesterday. This is going to go through the entire week, I think, because this is a very complex tool and will require quite a lot of work to make it work. Quite a lot of testing to see how it works actually. I have to test the performance and test how it does things to make sure that everything works fine. Let me take a look at something. Yes, and let me make sure also the bitrate is fine. Yeah, that's fine. Okay, I think we are ready to... Okay, let's take a look also of this. Oh, we had a problem here with the stability of the... Yeah, why? It dropped to several seconds, so I've seen that. It seems there's a problem here, but it's okay, we're doing fine. Okay, so the way I'm gonna go through this is that, first of all, the one thing I want to see if Zylann fixed the problem. No, he hadn't fixed the problem yet. There was a problem with the build that was failing, and he told me he's gonna add that, but it seems that he hasn't made a commit yet. I don't know what's gonna do there. Let's take a look. This is the pull request, but it seems that this one is fails. And yeah, he waits again for someone to reply to his message because there's one addition here that's not necessary. Yeah. Anyway, it's okay. If I have to, I don't think I will rebuild anything today because it's not going to be necessary. I'm not going to be doing any C++ code. We're going to be doing mostly JavaScript and Godot editor stuff for this week. So I don't think I will be doing any C++. Yeah, so the goal of the game right now, my goal for the game has been, when I start the game, I want to make anything from scratch, etc., because I didn't know what libraries existed, what technology exists. Now my goal is to use as many libraries, as many tools available for Godot, and make sure that I don't waste time developing things that other people have already developed. So when it comes to terrain generation, because Zylann has done, I think, a pretty good job here from the first look I've seen to the module, I don't think it's necessary for me to make all the stuff myself from scratch. It's absolutely, there's no way I'm gonna make all the things he made actually anyway, because this is a lot of work he actually put in this. So I was aiming for something much more minimal. Obviously his tools here, his Voxel tools, are very good. So what we managed to do yesterday is build this. It had a small error we managed to fix. Today I will just go through the documentation. I think the last time we were in smooth terrain, I think. We did smooth terrain. I think we wrote this documentation. Yeah, so let's start reading the documentation. Okay, let's go here. Let's say 19. Start reading documentation. Okay. So basically, this is the kind of look I was aiming for. Something that is going to look a bit low poly. I would like something instead of this. So I think I will probably go for a low poly look because I think it will make the game a lot easier to make if it's low poly. So yeah, so what we're using here is the Voxel load of terrain. Actually, let me open. How do I open it? I think. Actually, let me open the editor. Did I open it? So let's see. I think it was this one, right? Okay. So this is the scene we had yesterday. And the last thing we see yesterday is that there is a... What happened? The nice thing we saw yesterday... that's the Discord. Okay. So the nice thing we saw yesterday is that there's this kind of language here, visual language, like material kind of thing, where you can actually make your own procedural terrain using just visual scripting, which is great. I definitely will be using this. I don't know why, but it keeps popping the menu outside the window, and I don't know why. But anyway, so let's go about documentation. So it's not going to be terribly exciting for the first, I think today, tomorrow, because I'm just going through the documentation and make sure that I understand how this works. And there has to be a lot of written studying, because this is a really complex tool. But yeah, we have to read this. I think I read that. I think I understand now. You had to add the ST sphere not as a node, but inside the nodes in the visual language. So I had to go here and remove the plane and use a sphere instead. So where's the sphere? SDF? Here it is. So here is the sphere, in case I want to use a planet. Okay, how do I delete this? Do I use delete? Okay. Interesting, interesting. Okay, let's take a look at this because I can barely see what it's talking about. So this one is input X, Y, normalize. You can take a model and turn it to a voxel, eh? Nice. Oh, that's nice. You can voxelize models. Wow, I'm impressed. Interesting. It has a bit of artifacts. It has a bit of artifacts. Let's make the camera a bit lower. Wait, what? Or do I have to make it higher? I think I'll make it higher. Yes, I will make it higher, not that high. That's nice. So you can use range analysis. Basically what it says here is that you use a bunch of nodes to make the terrain. So there are two terrains here. One is created like this, one is created like this. And they are blended, of course, near the areas, right? But what it can do, this one can do, say that because they are both blended, after some area, they don't affect each other. So for that area, those nodes are not calculated at all for the corresponding terrain. So let's say for that area here, the terrain here doesn't gonna affect this terrain in this area here. That means the nodes here are not gonna be calculated at all. So this is some kind of optimization it does, which is very good actually, which call it local optimization. Oh. Today I didn't sleep very well, and it starts to show. I probably could fall asleep on stream at some point. But yeah, it's all part of life. I rarely have problems sleeping, but today I don't know what happened. I wake up at 4 or 5 o'clock, and then I couldn't sleep, and then I slept again at 8 o'clock. And wake up really late, at 11 o'clock. So hopefully today I will be able to sleep these 8 hours that I need. Okay. So, let's go to subdivision. So it seems that the node system that uses here, the graph system as it's called it, is very optimized. I see a lot of optimizations here, which I really like. Oh. Okay. So what do we have now? Streams. So streams is how it actually stores voxels into the hard drive. So you can take the terrain you generate and you can store it on the hard drive for optimization reasons. Or because you want to change the terrain, let's say you want to sculpt the terrain, which is very important when you do mining, for example. When you mine a terrain and you try to mine the rock, you mine the minerals, of course, you want the player to come back to the terrain and find the excavated part there, right? So it's not resetting the terrain every time the user leaves the terrain area. So you have to have a way to store this information, and this is where streams come play the role. That allows you to store the voxel shapes as they are affected by the user, so they are loaded later on, and the user can be able to come back and see the exact same result as he left it. So this is very important if you do things like mining on terrain, like you do in No Man's Sky, for example. You need some way to store this information, and that's what streams do here. Oh, wait. Ooh, nice. It uses SQLite as a database file for storing voxels. Nice. The nice thing about SQLite, it's called SQLite? I call it SQLite. SQLite, I don't know how it's called. SQLite, some people call it SQL. I call it SQLite. So SQL is basically the language that databases are using. If you ever work with databases, you know that you have heard about SQL or have heard about databases. And it's a very flexible language. It's not a programming language, but it's more like a documentation language. Actually, it is a bit of a programming language because it allows you to perform actions on tables of data. I haven't really worked with it very much. I'm not a database programmer by any means, but I do want to integrate database features inside the game. And I was thinking of integrating SQLite in Godot. By the way, there is a module or a library or an add-on that allows you to use SQLite from inside the script. So yeah, that's gonna be great that it uses SQLite, because it means that you can do a lot of flexible. Because the nice thing about SQLite is that if the service is light, basically it's light because you don't need a server, you don't need some kind of big database infrastructure to make the things you want to do, but still it has all the powerful features of SQL, which allows you to manipulate data very, very fast and very, in a parallel fashion, and you can do it in a way that is very flexible, which you don't have to implement any of those things inside GDScript, because the SQL basically provides those features for you for free. So that cut down development time considerably as well. So if you have anything that has to do with the database is anything, any data you store. It can be items, it can be enemy properties, it can be player characteristics and properties like traits and all this kind of stuff. Pretty much the entire game data can be stored in an SQL format, and it's very flexible because it allows you then to manipulate this data however you want, and slice it and dice it, and restructure it and very fast. Which will be a bit of a pain to do it through GDScript because you have to implement all these features from scratch yourself, where SQL basically allows you to have those features for free and do a lot of power stuff with them. So we definitely will be looking also on SQLite in the future. This game is going to use a lot of existing libraries, and there will be very few things like in most streams. In other streams, you're going to see people that basically make the game from scratch and they don't really use a lot of external tools because of the complexity of the game, and especially making a 3D game, which is also a building game, which also has procedural terrain generation. There is a lot of complexity there, and the only way to make this extremely manageable for someone like me, that I'm a beginner game developer, is to use as many of those libraries and tools that people have already made as possible. Otherwise, it will take me a huge amount of time to make anything from scratch, like make terrain generation, make database features, make I don't know what else I would be needed. Strategy systems or whatever, building systems. Even the build system that I want to make, I will make sure that no one else has made something like that, because obviously there's a lot of Minecraft clones out there. I don't try to make something that looks like Minecraft, but I'm trying to make something that behaves like Minecraft, which basically means you build things out of blocks and you assemble them together using voxels, and you make spaceships and star bases and ground bases using those blocks, those voxels. And yeah, there are many games that already do this in a Minecraft kind of way, so it's only a matter of time until I find a library that does this, that will save me time from doing these things only. And also there's a library for dialogue system or quest systems. There's a lot of libraries that do those things because many people make RPGs. My game will also have RPG elements. So all those libraries that are available for Godot right now, there are a lot of them maintained by developers, and they're pretty good, they're pretty powerful. And there are also many of them work also for Godot 4, which of course is going to be a main criteria to be able to use the library. Like this tool also works for Godot 4. And yeah, and eventually everything's going to port in Godot 4. I mean, actively developed libraries will be ported to Godot 4 because, you know, the future is Godot 4, of course. I think in a year or two, everybody will be probably switching to Godot 4 and have already switched to Godot 4. So my idea has always been better to switch early than later because, you know, having to port all this code to Godot 4 is going to be a pain, where now I can actually directly work with the Godot 4 code and not worry about those things. You still will have to change some of the code because obviously Godot 4 will have to make some changes along the way, but I think it's going to be a lot less work to start the project from Godot 4 immediately, even though it's a crashy, even though it's more unstable, even though it may have experienced some problems. Those, however, problems will be resolved in time because the game is not going to be released in the next year. Probably I would make an early access at least release in the next 3 years. And then, yeah, I would go have like a free versions uploaded on itch.io for people to test and try. So this is going to work like a demo, and then I will work for 3 years for free. And then after I feel that the game has evolved enough, I will start selling on Steam, stop developing on itch.io, and people can access the free version. That will be the older version, and then people that want to access the newest features and having the best version of the game pay for it through early access or maybe even a release. We'll see how it goes. So that's the plan there. So yeah, it's great that I use SQLite. I think it's gonna make things a lot more flexible for me because it means that I will be able to access this data and manipulate in a very flexible way instead of just using C++ classes where it will have been a lot more limited and it will require a lot of work from me to deal with this kind of data. Okay, so it has an automatic save when a block is unloaded, when it's too far away. And then it has a manual save, which can be called when we save the game. So yeah, generally when you save a game, you want to store this information about the scattering of the terrain inside the save game, like you will do in No Man's Sky, for example. So to make sure that the player, when he reloads the game, it sees all the changes he made on the terrain appear to him immediately. And yeah, this is how you do it basically when you have a save game. But also you want to save it when the player leaves the area and then comes back, so you have to also store it there, unless you keep it on memory. But sometimes it may be very expensive to keep everything on memory if the player goes around and sculpting everything. So yeah, it does deal with the streaming, and it does store things in chunks, so it doesn't keep anything in memory. It basically goes to store everything on the hard drive. Now that will be expensive for old hard drives, but new hard drives like the one I'm using, the M2 technology, are very fast in loading, and they operate in extremely incredible speeds. So, and because I will probably work with a really low poly terrain, performance-wise, this is not going to be. I don't think it's going to be a problem at all. So after that, we're going to go with instancing, editor, multiplayer, scripting, performance, model development, and changelog. And then we can go through the API documentation. Yeah, so this one is, what is that? So this one is the formats here. We're going to see those later. It's fine. I'm going to go through the entire documentation, so nothing's going to be missed. Yeah, okay, so let's go to the next section, which is instancing. So let's say he has multiple instances and send instances. But why we need a Voxel instancer node though? Because it's about spawning them on top of the terrain. Yeah, this is the rocks here. We see rocks and grass. And in my case, I will also like to add trees and plants and all this kind of stuff. Cool. Yeah, I mean, from the look here is very good. I mean, it's good enough for my game. That's actually very good. I really like it. Yeah, so basically he talks here about floating rocks. And this happens because when you position this to a low level detail, because you see it from a distance, right? And you have a rock on the surface, right? So you have a rock on the surface, but it's in a distance. So that means that this surface is in a low level detail. So it's going to take the face. However, if that surface has a noise, when it comes closer, it's going to fluctuate. Which means now there are new faces, but the rock has remained the same position, which means now the rock can be also floating. So that's exactly what it says here. It's how you avoid a situation where the items start to lose touch with the ground because that ground changes, of course, because of the level of detail. So if you come closer, it's going to be different ground from when you see it from farther away, where the rock is going to perfectly sit on the plane. And of course, when you have ground on a very light distance, is the fact is going to use huge polygons that are flat, and it will be very easy for the rock to lie on that flat surface. But when you come closer and closer, those big polygons will be subdivided to smaller ones, and in many cases they will have this kind of noise generation algorithm that is used by terrains that will make the terrain in some cases not have a good fit on the rock, or the rock basically being completely hovering on the air. So it says you how to avoid this situation by using something called offset along normal parameter in the generator associated with the item, which makes you properly takes into account the normal of the surface, so it knows how to rotate and how to position the rock or the item or the voxel instance on top of that, whatever you use. Maybe a rock, maybe a plant, maybe a tree. You're gonna see that happening sometimes with some games where rocks floating or trees are floating off the ground, and the reason behind it is because of this kind of error. Now, obviously, this library is going to have limitations. I don't expect it to be perfect, and frankly, I'm fine with that. I don't care about making something that's perfect or is going to be as good looking as in No Man's Sky. I'm not delusional. I don't expect my game to look like good and behave like good. If it works, it works. If it looks a bit like crap, it looks like a bit of crap. I mean, for me, it was never really a big issue. Because I still want to make a sandbox, and I still want to make something that will allow great degree of freedom for the player. So, and of course I don't want to waste my time. Sculpting the terrain manually and building the terrain in Blender will have been a lot of work. And it will be limited because player will have only a limited amount of terrain to play with. Where when you have a sandbox, you want an unlimited terrain. You want to be able to explore the entire planet. You want to be able to search every crevice of it, every corner of it, every piece of it. And experience the world with your own way. And I like this kind of freedom in games. I do love sandbox games. But on the other hand, sandbox games have also limitations. Sometimes they're slow. Sometimes you get these problems like this one here with floating things. Sometimes the pathfinding can be horrible. Nothing is perfect. Obviously, every game has its advantages and disadvantages. And you're just trying to find a way to do things the easiest way. And give the player a relatively good experience, because for me, again, it's not my goal to make a perfect game. It's more my goal to make a game that's going to have 1 million sales, something that a few thousand people will enjoy and having a good time and enjoy themselves, and makes a substantial income for me, enough to be a full-time developer. So I don't aim that high as No Man's Sky. I don't aim that high as even Empyrean, that is my inspiration. I don't know if I will be able to make something as good. But again, I want to give it a try, and I think it's very interesting. It's very interesting to work with SDFs. It's very interesting to work with procedural terrains. It's very interesting to work with procedural generation of graphics. It's such a fascinating field to use math to make all sorts of stuff like creatures or terrain or planets or solar systems. And even though I don't think I will go to the extent that No Man's Sky is going, I don't think I will go anywhere close to that. I would like to play around a bit with procedural generation and see how far I can go with this, and just see what I can make out of it myself. So I'm not trying to imitate any game here. I know that I'm mentioning No Man's Sky, mentioning Space Engineering as Empyrean, but in the end I'm making a game for myself, and it's going to be different, and it's going to be probably not going to be that good, but it's going to be good enough for me to sell it, and people like it, and hopefully have fun with it. So one of the things that are really interesting here, it says a secondary load system is included, which applies to meshes themselves to some limited extent. Godot 3 does not have a load system. Godot 4 will. So this is allowed to reduce vertex count over distance from within the set of visible meshes. So this is basically a typical mesh load. That is what really interests me, is how well it will take advantage. Probably this is a work in progress still for the module of the Godot 4 load system, because Godot 4 has a pretty powerful load system. It's not Unreal. It's not Nanite Unreal, obviously. You know, we don't expect this kind of stuff in Godot, obviously, because the development team is a lot smaller. But it still has an automatic load system, which is similar in the way that's automatic load to that of Unreal. Obviously, Unreal's implementation is much different and much more powerful, and it's made for extremely high detailed meshes, which is not the case with Godot, of course. But I think it's a move towards the right direction, because automatic loads will become the future. It's definitely a technology that we will be seeing more and more in the future. And it's a great advantage for the developer to come with a high-level detail model inside the game engine and be able to generate the low-level detail automatically without him going back to Blender and making a medium-level model and then making a low-level detail model, which is, of course, extra work. In my case, it's not really that important because I will probably go for a low poly game for performance reasons as well, and complexity reasons, because the less detail you have in a game, whatever it is, it can be game detail, and less complexity, the much easier, of course, it is to make the game. So for me, it's important to make the game very easy to make, and I want to remove every extra fat, everything that is not necessary, because, you know, you can take a look at something like Star Citizen, which is photorealistic. It has amazing and super realistic, realism when it comes to planet generation, etc. But do you really need that to make a game that's fun? And the answer, of course, is no. You don't really need that. Of course, people that are attracted to photorealism, they're gonna go after something that's Star Citizen. But there's I will say, vast majority of players don't really care if a game is photorealistic or not, which is why something like No Man's Sky has become so popular, and it still is more popular than Star Citizen, because people don't really care how realistic the game is, as long as it looks good, or as long as it's fun to play, you know, that's fine. So the idea is what we can remove from a game until we get to the point that's no longer fun. And the fact of the matter is that we can remove almost everything, because there are games out there that even are text-based, that use no graphics at all. Like you have Dwarf Fortress, for example, which the graphics are very limited. It still is a very procedural game. It has a lot of similarities with No Man's Sky, as a matter of fact, because it takes a lot of procedural generation. It's nowhere near as popular as No Man's Sky, because I don't think it's more like because it doesn't have graphics, but it's also because it's a very, very pain in the ass to learn and use and operate. The UI is pretty horrible. And that's just basically what the developers are saying, that the UI is not really that good. But it's a very popular game still. It's still an extremely successful game, a great game, a fun game. It has features that No Man's Sky can only dream of, like procedural generation of characters and all crazy stuff that those characters are doing, and people coming with these beautiful stories that seem so logical and that you cannot believe that a game can actually come up with these stories, and yet the game is capable of making some basic storytelling, which is procedural. So it really shows you that even if you remove something as basic as graphics, and you say something like Dwarf Fortress will never become mainstream, but it is a mainstream game because there are a lot of people playing it. And as a matter of fact, you're going to find a ton of YouTube channels that actually are dedicated to Dwarf Fortress. And many streamers that play games like No Man's Sky, they also play Dwarf Fortress on the side, and they're actually big fans of the game. So it really shows you how much you can remove from the game to make it enjoyable, and still very, very enjoyable. I mean, if you have a game like Tetris, which is super simple to make, I mean, obviously you can have a sci-fi game with low poly and, you know, low level of detail and low complexity that can be still very, very interesting to play. So that's my goal there, is to make a game that's pretty simple and it's not going to take me like forever to make it, and yeah, release it. So let's see what happens here when God of War gets a load system and we have a much more integrated thing happening between this module, which probably uses all load system, and the load system of God of War. So this is something that's interests me to see how they're going to integrate one another. I think it's going to be very interesting. So it seems that it doesn't have a load system distance. Okay, so personally, I'm not really interested so much on the load system because, as I said, I'm going for a low poly game, so it shouldn't really matter that much for me. So yeah, and the game will be engineered around the limitation of these libraries and the game engine itself. So obviously anything I will make will depend on how well those libraries are performing, how many features they have. You know, obviously something like Godot that doesn't do photorealism that well, you're not going to be using it for photorealistic games that much. So if some things are slow, then we'll lower the resolution. If some things become not performant, we will lower the amount of things that can be on the planet or the surface, etc. If there are some things that cut performance, we will remove them. We will have to adjust the game to fill the demands of the limitations of the engine and the tools, the third-party tools I will be using. We will have to get used to the idea that we have limitations and things we will not be able to do as well as we will be able to do in other game engines. But in the end of the day, the reason why I'm using Godot is because I love working with JavaScript. I think anything that's Python-like, I'm a huge fan of Python, and the fact that I can use the JavaScript, I also, my first thought was always to use Python directly, but since I see that it's too much work to do, using JavaScript is also, it's a compromise, but it still is a fine compromise over just using C# or using blueprints in Unreal, which I don't really like that much. I feel they're very limited and not that, that's not really that well performant. I do like working with Godot because I think this engine has a very nice design with the node system and all this kind of stuff and the way it instances scenes. And I do think that Godot developers have done a very good job. And I do like the idea of working with a simple engine. Even though it limits my game design, I do like simplicity. I do like that I don't have to spend like months and months and months reading documentation, right? So this tool, yes, it's very detailed, it has a lot of documentation, but still, it's only take like a week or two to really understand how it works. If we were going for something much more complex, like a professional terrain generator, it will have been able to have hundreds of pages of documentation, which will take months to really read and study and master. I mean, take a look at Blender, for example. Someone wants to learn Blender, they have to spend tons of months, even years to really understand how, not to master the artistic skills, not to master the application, but even to learn how the application works. It can literally take you years. So it's good to have tools that are limited, that save you time from learning things, because you can still do an amazing set of things. A guy can make amazing things using a pencil. So of course, even if your tool is much more simple and limited, you can still do amazing things with it. And I don't want to waste my time going through documentation, going through videos, tutorials, and just not making the game. I want to get to making the game as fast as possible, which is also why I use these tools as well. Even though I spent time on adding documentation, right now I'm saving myself time from developing the same code. Especially this code would probably take me years to develop, which of course I don't have time for. So it says the freedom has a value. Okay, so multi-mesh are fast and efficient but are quite limited. Instance scene is supported by the items of type Voxel instance library scene item. Instead of spawning multi-meshes, regular scene instances will be created as child of Voxel instancer. The advantage is the ability to put more varied behavior on them, such as scripts and blah blah blah, animations, or further spawning logical interaction. The only constraint is the root of the scene must be spatial or derived from it, which is fine because I think almost everything in 3D is 3D related, not spatial, so that's not going to be a problem. This freedom has a high price compared to multi-mesh instances. Adding many instances can become slow quickly, so the default density of these items is lower when you create them from the editor. It is strongly recommended to not use too complex scenes because depending on the setting can lead to freeze or crash of Godot if your computer cannot handle too many instances. Okay. Right. Okay. Now, one of the great things is because we code things in C++, it means that I may also be able to make a fork and start adding my own features in this library if I want something specific. Which is why, doesn't necessarily mean that everything will be done in C-script. Most likely I will be using C-script for most things. Yeah, you have to modify some of the code or extend it with using my own C++ code. I'm not going to hesitate. And here we go to the editor. So next we have multiplayer. I don't think I would do in multiplayer with the game. My first choice has been not to go with multiplayer, start with a single player game, and maybe in the future, distant future, if the game goes well, add also a multiplayer option as well. We'll see. I don't know, maybe I will keep it with single player as well. I'm kind of a big fan of single player games anyway. I don't really care so much about multiplayer. And from what I've seen, most people play, even when they play multiplayer the game, they play it like a solo player kind of thing. So most people play the game solo, so I don't think multiplayer is really that needed for games. Unless you have like a group of friends you play the game with, or another friend you play with regularly. It will make little sense for you to play multiplayer, unless the game itself is multiplayer by nature, so it's a PvP game, for example, where there, of course, you don't have multiplayer. It's pretty much... but these games, they tend to be more single-player kind of experience. So I think making them single player will be better. Also, it will be better in terms of performance. So yeah. Multiplayer is an experimental phase. Okay, that's more of a reason not to do multiplayer then. So, okay, so multiplayer again probably is not something I'm gonna be doing. I'm testing the stream a bit, so give me a second. I want to see how the compression works. Yeah. Okay. Okay, so where we were? Server. So it doesn't work with Voxel low terrain. So yeah, this is exactly what we're using because we'll be doing mostly soft Voxel terrain. So if there's no support for this, it means that multiplayer is not going to work for this case, which is another reason for me not to do multiplayer, which is fine. Yeah. Okay. So yeah, this is more like for Minecraft kind of games. If you want to do multiplayer, it's not for the kind of game I want to make. So that's fine. I don't care about multiplayer so much. So we move to the next one, which is scripting. Now that's important, because we have to see now how the Voxel tool is controlled through GDScript. And how we can control the generational terrain and the generation of the planet and the solar systems from inside GDScript. So Voxel is basically like a helper class that allows you to have an easy way or an easy set of methods to allow you to quickly manipulate the Voxel terrain. Okay, so this is what we care about, and of course we're going to care about accessing the SDF because we define the voxel and the terrain using SDFs, because in our case we're using a smooth terrain instead of a blocky terrain, a Minecraft terrain in essence. Okay, says here, similar to bounce limitation, when you load a load with voxel load terrain, it's not possible to access or edit voxel beyond the first level of detail level. So what it means first level of detail is the high resolution or the low resolution is the first level of detail. That's one thing I don't remember. Past this level, voxel data is no longer available at full resolution. Access to voxels and multi-threading. Where is that? Probably it's in performance. You can access make the generator script. You can also do it in C++. Ah, nice. And C#. Cool. So that can be very useful for performance reasons. Oh, let's drink a bit of water. And now we go to the most important part, performance. This is usually a big thorn when it comes to procedural generation It's that procedure generation is great and amazing. You can make planets, you can make an infinite terrain, but it comes with a cost. And if you do things really weird and really complicated, it's gonna slow things down. Because we're not gonna be using the GPU for those things, right? Because I want to avoid making shaders and compute shaders. That will complicate the game even more. I would like to keep everything on the CPU side. It's a lot slower, of course, but it's gonna make things a lot simpler. And yeah, but generally I don't think I will have a big problem because my game is gonna be low poly, so it shouldn't be an issue. Because I have experience from Empyrean Galactic Survivor, which is a building game with procedural generated terrain and voxel system and building system. And it kind of slowed down, but you have to say, I think the game is coded in C#, which is a lot slower than C++. This implementation is of course coded in C++. And yeah, I think it should be fast enough because I want to go for something low poly, where Empyrean is not low poly, it's actually a high poly game. It tries to be a bit realistic. Yeah. So it uses here threads, of course, multi-threaded, the nice thing about this tool. And it makes sense because usually voxels are easy to multi-thread, which is why it makes them also good candidates for GPU acceleration. So you can actually accelerate voxels on the GPU as well. Although this module does this yet, I think probably in the future it will be a natural evolution for this module to allow you to have voxel terrains that are generated on the GPU side. But I really think that even No Man's Sky is doing most of its procedural generation, even for animals and plants, and of course terrain on the CPU and CPU alone. I don't think they're using GPU so much. Because it was made to run on a very old hardware. And of course, if you don't want to do procedural generation on the GPU, you have to use what's called compute shaders, and there are many older GPUs that don't allow you this kind of flexibility. Especially with Vulkan, you need to have Vulkan, of course, for compute shaders in case of Vulkan. It does have compute shaders. Otherwise, you have to use something like CUDA but the problem with CUDA is it works only for NVIDIA, or OpenCL, which works only, I think works for AMD, but I think it's slow on NVIDIA because NVIDIA, you know. So it's a bit of a pain, so I think most people prefer to use things like Vulkan compute shaders. And also, the one thing that's very popular is, I think DirectX also has its own computer shader language, which allows you to do this kind of stuff, which is very multi-threaded on the GPU instead of the CPU. But in this case, we're going to be based on the CPU because the game we'll be making is going to be low poly, so it's not going to need that much performance. If No Man's Sky can do it, I mean, there's no reason why my low poly game would not be able to handle its complexity on the CPU. So this module here is definitely used the CPU, using multiple threads. It seems to be automatic. It uses all the uses all the CPU cores. That's gonna be tricky on my system because I have a 12-core AMD CPU, 12-core, which means I get 24 threads, which of course is quite a lot for most people. I got the 12-core because multi-threaded is very important law where you compile C++ code, so it makes things a lot faster. So I would like, of course, the game to run on, I will say, quad cores minimum, right? A quad core usually has 8 threads, which of course is 1/3 of the amount of threads I can have on the CPU. So I have to be a bit careful there, not to allow the game not to count the performance, have the performance basically cut down to 30%, so to make sure that people have quad cores can run the game without any issues. So profiling is also another big thorn when it comes to these games, is that you have to make tests and make sure that you know how many threads are run, how fast does run are executing, how much time they take for each execution to do, to make sure that you know that the code is going to perform well, also not only just on the hardware, but even lower spec hardware as well. Okay, so it's automatic. Can you? You can set it though. I think you can set it though. Yeah, you can say how many that's actually very good. Because I would like to limit it into basically if you have quad core 8 threads, so probably 6 threads, because you need to level up a couple of threads for the operation system, maybe for the main thread of the game and the game engine. So probably 6 to 5 threads should do the trick. One thing to know here is that if you can actually generate more threads than you have available on hardware. Those are called software threads, but if you do that, you slow down the code considerably. This is important if you want to do things concurrently and you don't really care about performance. You just want to do many things at the same time and you don't care how much time it's going to take. This happens, for example, if you do rendering or something like that, which is going to be what you call offline, which basically means that you wait until the result finishes. But because in games we have real-time performance and we want to do things real-time, we of course don't use software threads, we mostly use hardware threads. Something like Python and GDScript usually are using software threads that don't directly access hardware threads. But you can use hardware threads as well. So I think this one probably will be using hardware threads, or so usually is referred also as operation system threads. Where the software threads also sometimes are referred to as green threads. Or greenlets, I think they're called sometimes. So threading is definitely one thing we can avoid here, because threading is a very complex way of coding. There are a lot of caveats and you have to be very careful how you write your code. You have to write in a specific kind of way to take advantage of the advantage of performance boost comes out of threading. If you do any kind of mistake, you lock your thread, you unlock it at the wrong time, you make your thread wait, you're going to lose all this performance, and you're going to have code that's much more complex than writing code on a single thread, which is why still a lot of games rely on single threading instead of multi-threading, because it's just easier to debug, it's much easier to modify and maintain as a code. But yes, things are like that, which is voxels, which we have many blocks that generate terrain at the same time. It makes sense to make them multi-threaded. And as a matter of fact, as I said, voxelization works very well on a GPU as well, because you have something like 4,000 blocks ready at the same time. A GPU can do that very easily with thousands and thousands of GPU cores that it actually contains. Although the performance is not 1,000 times better than CPU, usually it's like 4, 5, 10, 30, 50 times faster if you do it correctly. And the reason behind that is because GPU cores are far less performant than CPU cores. CPU cores are designed to achieve higher performance and higher CPU clocks, where GPU cores are meant for more lower performance parts, but they are allowed to have many things running at the same time, which you cannot do on a CPU, which you have a very limited amount of threads available. Now, it basically says what I say here. It's recommended not to use all the available threads for voxel stuff. Games use more for other things, and players may even do something else in the background, such as music, YouTube, deploy vest, or voice type. So basically, in a quad cores, and I think dual cores, 8 cores, 6 cores, etc. They're using what's called hybrid threading, which means that you get 2 threads per core, which means if you have a dual core, you get 4 threads. If you have a quad core, which is 4 cores, you get 8 threads. And you have to take into account that every time you open a new application, the operation system will assign a new thread to it. So in reality, you may think, okay, I have used this thread only for my game code. No, that's not the case. That hardware thread is actually does other things at the same time. It can do things for your game, but also you can play YouTube videos at the same time. You can access the internet at the same time. You can play audio at the same time, which is unrelated to your game. You can play YouTube audio, for example, like I do right now, as a background music. So even though you say, okay, I'm going to use 6 threads in my game, and I have an 8 core, which can provide me with, 4 core, which can provide me with 8 threads. Even those 6 threads may not be dedicated to your game. The operation system will decide how to use those threads, and in many cases will use them some for the game, and then it also can use the same thread for something else as well. So this is a good reason why you shouldn't use the maximum amount of threads on your CPU when you do something game development wise, because the threads already are used for other things at the same time. So you need to keep things as the multi-threaded as limited as possible. So you use multi-threaded only if it's really important and really necessary. So this is what it says here. You should not use all available threads, because of course that will mean that you see the computer slow down, obviously. Games use more for other things, and players even may do things from account, like as say music, YouTube, play voice or voice chat. The module uses one additional streaming thread for file input. So you already lose one thread because it does the streaming, which basically streaming, as we said, is the voxels that are stored on the hard drive that you stream directly to the memory. So basically the terrain you can sculpt it. So it already uses one thread for that, which is always reserved and will count the amount of threads allocated. It's not possible to use 0 threads. The module is designed to use threads at the moment. Makes sense. You can check at the random how many threads are allocated with the script using Voxel server get stats, which is fine. So open in the debug, verbose the arrow, which is enabled in project settings or V command line. Changing these settings requires an editor restart to take effect. Okay. So basically, probably it requires an editor restart because those threads are also used inside the editor because it renders the voxels also inside the editor, which makes sense that we'll need to restart the editor as well. Some tasks will have to run on the main thread, and sometimes the total time can exceed the duration of the frame if we were to add all the remaining things that have to be processed. To mitigate this, the module has an option to stop processing these tasks beyond a certain amount of milliseconds and continue them over the next frames. Okay, so there's a timeout where after some time it stops using those threads. Okay. There is a load distance. Okay. Well, what's it? Did you say earlier that there was no load distance? Or the load distance was not? I think it said you couldn't set the load distance. Wait, what? Why it says now that you can reduce the load system? I'm confused. Yeah. That's the OpenGL thing. I don't care about OpenGL because I will be using the Vulkan. That is a problem. He says here that if you move too fast, it really slows things down considerably. That has to be tested as well. If you have a lot of small mess on terrain, which will be the case because we have to have plants, we have to have forests, we have to have trees. So that has to be tested. I've seen some demos, but I haven't seen any slowdown. But they haven't been that busy, so we have to take a look and see exactly when it slowed down and why. So where are we now right now? Okay. So I think we finished with the main documentation. We have the change log. Okay. So the 506. Right. This is the ongoing development. Okay. So I think this came in a very good time. Let's take a look at this as well. Right. Let's take a look at this as well. Okay, so we finished with the main documentation, which is the main area, which basically is the tutorial, the main tutorial section. And now we're going to move to the API reference, which is of course important for the scripting part. And then we can go with formats here if we want to understand how the formats are working. The API of course is going to tell us in much greater detail what we can use with this module. So I'm going to go through this. I'm not going to go to every single one, I'm not going to go through it in very high detail. So in the next stream, there will be in a couple of hours, I will come back and study, gonna study the API reference in much greater detail. And yeah, because I want from tomorrow to start playing around with the API. Today it was Tuesday, so I want Wednesday, Thursday and Friday to start playing with the API. And yeah, starting making the terrain. Of course, starting playing around with making terrain and making procedural terrain. So I realized that today wouldn't be a very interesting stream because yesterday, because obviously yesterday I was building the tool and I was taking a first look at the documentation. Today I'm taking a bit deeper look at the documentation, but I hope today to finish one fast pass through the API and very, very fast go through also the formats here, which I don't think we'll be using anytime soon because they are just more, for more low-level access to the way that the data is stored inside this module. But yeah, we have to have a good idea of how the API works, at least a basic idea for the most popular classes, and the classes will be focused on because of course it has many different classes, and I'm only interested in things like the Voxel load terrain, which is something like this, which is instead of the block terrain, which I don't really care. So we will not be more focusing on every class because obviously some classes are made for Minecraft games, other classes are made for more realistic games. I'm more like mine is going to be semi-realistic, so it's going to be more on the level of detail kind of terrains. So yeah, so we will be focusing on those and we'll go through this really fast, take a look at what kind of methods he has. Obviously we'll be good taking a deeper look on them and coming back to them every time we write JavaScript code for this. But yeah, tomorrow I will start making the terrain. I will start seeing how I can make the terrain, what kind of algorithms can I use, what kind of works, what doesn't really work, testing the performance and all this kind of stuff. So I'm going to end the stream right here. Thanks everybody for being here. We take a look at a deeper look today on documentation. I will come back and we finish with the tutorial section of the Voxel tool. We're gonna go through the API reference in a couple of hours. I will be back for another 2-hour stream. And I will go through the API reference, and take a bit deeper look on how the internal classes work in the Voxel generator and the terrain generator. And tomorrow we will be starting making the terrain inside the editor, which I already start doing here. But of course, we still have to play around quite a lot. It's going to be quite a lot of playing around with the visual language that it has for making terrains. And of course, making the terrain that's going to be interesting. And it's going to be a planet. Because I want to make a planet. I want to make a planet, a solar system, and all this kind of fancy stuff. So the big question is, how are we going to do this? There's some tutorials already mentioned ways to make planets. So I think we are pretty covered in that respect. But we have to show how it works. We have to implement models and test, what happens when you plane a spaceship inside, what happens when you make a star base inside or a ground base. So all these things have to be tested: how to make trees, how to make rocks, how to make minerals, how to excavate the minerals. So the next few months will be dedicated to this tool, making the terrain and making sure that the player can explore the terrain and play around. And of course, making release builds that I will uploading on each I/O that will allow the players and people that watch the stream to come and test this and give me feedback back whether it's stable, whether it's not stable, see how well it works on Linux, how well it works on Windows. Because I'm mostly developing on Linux, but I will also of course release for Windows because pretty much almost everybody plays games on Windows. So yeah, I think I'm done for today. For this stream, sorry, not today. I will be back in 2 hours. And now let's find someone to raid. Let's see who is available that does Godot engine stuff. So we have one guy here. What? That's Japanese. We have 2 people here. Okay, so let's take a look. We have one which does okay, let's take a look at one again. Let's take a look at this guy. Let's see.
Bon, alors du coup on peut virer le flash.
No, that's French, so that is not gonna work for me. And this one is English. So is it English? So no. So it seems that we'll rate one of the people that don't do Godot because it seems that we don't have an English stream right now. So okay, so let's raid. Let's see who we're gonna have available for raid. Let's raid Togglebit. And yeah. Thanks everybody for being here. I will see you in a couple of hours. And yeah, let's start with the raid. Bye bye, everybody.